All right, so like I said, today should hopefully be a short day. We just have to talk through a couple of triangle theorems. There's going to be a lot of triangle theorems kind of in the upcoming chapters and upcoming topics. And so we want to get a little bit of a head start there. The reason we're bringing these up here now today is because they're in relation to the other theorems we've learned so far. And so if you think about like corresponding angles, alternate interior angles, alternate exterior angles, same side interior, they're really designed to help you understand how angles relate within a shape. And you got a taste of that yesterday when you saw like those angles attached to shapes, but still kind of playing with two parallel lines. And so that's what you're going to see today as well. Before we start, let's talk about interior and exterior. This is fairly straightforward. So let me get some class participation here. If I say interior, where am I talking about?
Inside.
Yeah, so interior as a general terminology means on the inside space. And so geometry steals that directly. In terms of the shape, we tend to think of the angles more. And so when we talk about interior, we're actually talking about the interior angles. Wow, okay. Okay, and so of course with a triangle, we have three interior angles because we have three vertices. Keep in mind that this term right here is still vertex. Vertex is still the corner of any shape or confluence of two different lines. So that's pretty straightforward. Let's talk about the exterior space. Well, that's definitely going to be the space on the outside. But where does anybody have an inclination about where the exterior angle should be or how I can draw it? This one's actually a little bit tougher, but I wouldn't mind some guesses first.
Continuing one of the sidelines past the vertex.
Anna, tell me more about what you're talking about because you nailed it. This is a good thing.
So like the left side, you would take the line and then just draw it up past where the two lines meet.
So like this?
Yeah.
Okay, now that actually creates two angles. Which one are you talking about, the straight angle or the acute angle?
The acute angle would be the exterior angle.
Ah, very good. So Anna's reminding us that the exterior angle is a very specific angle on the outside. The most common incorrect answer I get for this question is like this angle right here. That actually is an angle in geometry. This is something called the reflex angle. The reflex angle is the entire angle that's not the interior. And so when you add those two together, they have a relationship, the reflex angle and the interior angle. What relationship do you suppose this interior angle and the reflex angle would have at this intersection, at this vertex? What relationship makes the most sense?
They would be supplementary to make 360 degrees.
So let's be careful. Supplementary specifically says you add to 180 degrees. And so you couldn't say it's supplementary and it adds to 360. But you are correct about this. These would sum to 300. Ooh. These would sum to 360 degrees. Okay. In the same way that if you looked at the exterior angle and the interior angle together, those would inherently have a relationship. What would that be? Like these two angles. This should be automatic at this point, I think.
They're supplementary.
They are supplementary. And it's important to note that the way that Anna instructed me to draw this exterior angle is not unique. So I could have drawn, and you don't necessarily have to add this to your notes because it could get messy, but I could have drawn the exterior extension this way. And so this right here would have been the exterior angle. And that happens at any intersection. And so I could have drawn the exterior angles here or at the reflex angle. I'm just trying to demonstrate that there are three different types of angles that occur in triangles. You have the interior angle, which of course is on the inside. You have something called the reflex angle, which is everything but the interior angle. Or you have the exterior angle, which forms an extension from the main shape. Okay, so just a little vocabulary to establish before we actually dig into the meat of this, just so we, when I use those terminologies, you know what I'm talking about. What questions do you have about this? Anything I can clear up about where the interior angle is exterior angle is, and reflex angles are. Okay. So the truth is in geometry, the reflex angle is fairly boring. Because it's everything that the interior angle is not, the sum always being 360, it tends to be a straightforward concept. And so we're going to focus our attention on the interior angles and the exterior angles of this shape. And we're going to focus mainly on triangles today. Okay, so let's talk about interior angles of a triangle. For a visual, let's sketch a triangle. It doesn't matter what shape of the triangle is. Let's just like sketch a triangle so we can associate that with the interior angles. Okay. And so as labeled before, the interior angles are the three of them, of course. And just for our purposes, we'll label them 1, 2, and 3. I have a feeling this is purely review at this point, but let's go ahead and say it out loud anyway. What must be true of the interior angles of any triangle? What's the rule?
Don't they add up to equal 180?
So make it a statement. Even if it's wrong, I still want it as a statement. So what's true of all the interior angles of any triangle?
They add to 180 degrees.
They add to 180 degrees. What's another terminology for that? If you're saying it adds to 180 degrees, what else could you say?
They add up to equal a line.
Okay, so they can form, so like they would be the equivalent of a straight line. We have to be careful because the angles don't actually reform, or the triangle doesn't reform. But there's a terminology starting with the letter S that means the same
supplementary
thing. There it is. And so what we have here is actually an idea. We call it the triangle sum theorem. Okay, and in case it hasn't been made clear in the past, we've been kind of trying to like sprinkle this in. This word theorem has a basis in the word theory, which is an idea. And so this is the same thing as kind of like a rule. Okay? So the reason why we call it more of a theory than just a straight up rule is because it demands more explanation. It's actually not as obvious as, let's say, like the corresponding angles postulate. And so in geometry, when you hear the word postulate, you're talking about something that tends to be more obvious. When you hear the word theorem, it's something that tends to need a little more explanation. In terms of the rule, it's just what you guys said. The angles of a triangle are supplementary. Okay, and so using our example, if we take the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3, they must sum to 180 degrees. All right, so let's just get that down as like a rule. The common abbreviation for triangle sum theorem is TST. And so if you ever see TST, I'm referring to the triangle sum theorem. Okay, by show of hands, how many people knew of this rule, remember a teacher talking about this rule, or just like had it in their brain to begin with? Just like quick show of hands. I just want to take a quick survey. Yeah, thumbs up or hands up, whichever. I'm just like looking. Only 2 people? I don't believe that. Only 2 of y'all? No way. Okay, there's a bunch more. Okay, and so here's why this is a theorem. Okay. We're going to be in school at some point. Okay, I think that's going to be true. Like some before the end of the semester, I think we'll actually see each other face to face. I will buy somebody a soda the day you guys come and see me in class for the first time ever, if you can tell me why this is true.
I can tell why it's true.
Because a triangle is half of a square, and a square adds up to 360.
That's half of a circle or half of a square, the one that I had drawn on the board.
It's half of a quadrilateral at least.
Okay, so if I can buy that. Now, no one has to write this down because we're just kind of postulating right now. And so you're saying it's kind of like half of like a bigger 4-sided shape. That brings up a bigger question though. Even if I accept that, I think it was Evelyn who said that, right? Let's say I accept it as an answer, right? That still doesn't explain why a quadrilateral adds to 360. So you just created a new problem for us. No, I appreciate the attempt. Please don't, this is not me shooting you down a ball of fire. Like, this is how geometry usually is actually operated. Like, we just kind of throw ideas out until something starts to make sense and we can explain it. And so I love the attempt. I really honestly do. Okay. So like, just to be clear, Evelyn's attempt was to kind of say, well, triangles are like half of like a bigger four-sided shape. We know that four-sided shapes add to 360. Therefore, this should add to 180. It's a beautiful piece of reasoning, but we don't know why, unless you can explain why quadrilaterals add to 360. Unfortunately, doesn't explain this phenomenon either. Anybody else want to take a shot at it? Does anybody know?
The number of sides that it has?
A little bit louder, Delaney.
Is it because of the number of sides that it has?
In what sense? Like, give me some more information.
Like, a triangle has 3 sides, but then like a quadrilateral has 4, so it has more angles.
That actually does tend to add to the logic of it, but that doesn't explain why a triangle has the interior angles of a triangle have to add to 180. I love that, and we're going to use that logic. Actually, we're going to take that very piece of like thinking, and that's going to help us extend to more than just 3 or 4 sides. But I'm still asking about just a triangle. No takers. Okay, here's what I'm going to guarantee this before we start. Oh, does someone want to throw in?
What about the fact that like something that gets to 180 usually like by a 3, so you can like 6 times 3 is 18, like 9, and times 2 is 18. 9 divided by 3 is 3, so that might be partly why. And like there's 3 sides to the triangle.
No, I think that's actually a really nice attempt because you're noticing number patterning. And that's where actually most mathematics is done, by just like simply observing patterns and behavior. And we can extract a lot of good like rules from that. That's actually the nature of equations. You just kind of notice how things behave, and then you just generalize into an equation. I think we can use that as a jumping off point. Here's my guarantee before we start. Every person in the room actually knows the answer to this question. You just don't realize you know the answer to this question yet. And so like the way mathematics is, particularly geometry, we always want to build upon what we already know and have established. And so think about this unit so far. Do you know any relationships where you have angles that add to 180 degrees?
Linear pairs.
Okay, so linear pairs add to 180 degrees. And so we can use that. Are there any other relationships that add to 180 degrees? Let me rephrase. What other relationship do you guys know of where the angles end up being supplementary?
Same side.
Say it louder.
Same side.
And that's my abbreviation for same side interior angles. No, this is actually a really good thing. What that means to us is that we can basically build or start with a very familiar picture and see if we can't like use the relationships that we already know to establish the rule. And so if we're talking about same side interior angles, what must be true of these 2 lines before we can talk about them being supplementary?
They're parallel.
Thank you. And so let's try to draw them as parallel as possible. Now, of course, we can compensate for like my lack of precision by doing this. Okay, what else must we have in this diagram if we're going to have a shot at using same side interior angles?
We need a transversal. Transversal,
yeah. Do you think it matters where it goes?
No.
In fact, mathematically speaking, we don't want to lock ourselves into any one particular configuration because it has to work for all configurations. Like that, I don't know if they explain that very well in algebra, but that's the whole point of algebra and using all the x's, because if you can prove it happens for x, it works for any number that you can use for x, and therefore you can use it for anything. So here we have a transversal. Now immediately we have all these angle pairs, correct? But knowing that we actually are talking about the interior space of a triangle, what else do we need?
The angles. Number the angles, like degrees.
Oh, we can number the angles. Like that's going to be like an arbitrary thing. But we're trying to investigate what happens with a triangle. Do we have a
The
triangle yet?
second intersecting transversal.
Okay, Anna, tell me about where this transversal must be.
The transversal has to intersect both the two parallel lines and one of the points that the other transversal intersects the lines.
Okay, someone other than Anna, why is she giving me this direction to do this? Intersect the parallel lines and the other transversal. What is she attempting to create?
A triangle.
Yeah, absolutely. So if we can understand how the angles behave on this particular diagram, because we have cleverly built a triangle out of these two parallel lines and transversal. Okay. And just for the good of everyone at home, I use that phrase anyway. I guess it literally means everyone at home now. Okay, that's the triangle I'm talking about. Okay, now in terms of, so Ethan gave us the idea to label the angles. I agree, we should totally label them. These are going to probably be the most important ones. But we should probably consider like that one as well.
Mr. Collins,
Yes.
why would the outside angles be numbered?
Well, that's a great question. So if I'm looking at angle 5, why might it be important to consider angle 5, even though we're just looking at the angles of a triangle?
Because it's an exterior angle from the triangle.
5 actually isn't an exterior angle.
Well, from the triangle though.
From the triangle, it still isn't. The exterior angle on this one would actually be all the way to here.
Okay.
So the short answer for that, Ethan, is just because I don't know which ones we may need or may not need to help us understand what's going on.
Okay.
Okay.
Got it.
All right, cool. So let's do a little investigating, and then I'll try to give you some sense of the dynamicism of all this. So let's just like suppose something. Let's just suppose angle 4 is 100 degrees. So tell me some more information that you can get from this information. Like, in other words, what other angles do you know?
Angle 3 is 80 degrees.
Okay, can you give me a quick reason why?
Because 3 and 4 are supplementary.
Okay, linear pairs are in effect, right? Okay, any other angles that you know?
Angle 5.
Has to be.
Same side interior, which means supplementary.
I don't know about angle 5. Oh, I see what you're talking about with 100. So what's the value of that angle have to be?
80.
Okay. I guess we could also go an alternate interior there. That's where my mind was. But yeah, no, that should totally work.
Oh.
Okay. Any other angles?
6 is 80.
6 is 80. Can you explain why?
Because it's I don't know. It's vertical from 4.
It's not vertical. Vertical angles would be touching.
No, it's not.
So, I appreciate the attempt, but it's important to investigate. So these have to be touching to be vertical, so they can't be vertical. Let me offer a thought for you. What if I went all the way from here to here? Do we know that value?
No.
Yes.
100.
We do. Can someone explain why it has to be 100?
Because 80 and angles 6 and 2 together are, or angles 5, 2, and 6 are a linear pair, which means that all of them together are supplementary. So 6 and 2 have to add together to make.
No, I like that. And you can also explain it, I think, by same side interior. And so if you look at like angle 3 and you look at 6 and 2 together, they're going to be same side interior for that transversal. And so we may need a little more information to just to finish this out. But what if I told you angle 7 was also going to be 120 degrees? What could you tell from that?
It's going to be 80.
What's going to be 80?
Angle 6.
Okay, so angle 6 has to be 80
I was
degrees.
thinking 60, but I
Oh,
could
I'm
be
sorry.
wrong.
Oh,
No,
yeah,
I'm
I'd
sorry.
be
You're right.
60.
60.
I did the math wrong. Yeah.
And we're with you. So it's going to be 60 degrees. So what else can you tell?
Angle 2
Are you
is
asking me?
Anybody, really. So angle 2 has to be 40. That's what I heard. What's the measure of angle 1?
60.
Okay. So before we kind of like understand like what you guys just revealed, which is actually a very rudimentary form of what we call geometric proof, does anybody doubt any of the values that we put on the board so far? And I'll also point out that like all the values were born out of, yes, some given information, but really you guys did a great job revealing a bunch of relationships. And so like the relationships of like linear pairs to guarantee these has to be supplementary. The same side interior angles also being built on supplementary. Alternate interior, more linear pairs. And so all these relationships lock these angle values. This is a lot of the exercises we have done up to this point where like we've given you one angle, and based on that one angle, you guys found like 7 to 14 more angles. That's because like the behavior of one angle can affect the entire diagram of angles. And so another way to ask that is if I change this outside angle to 100, okay, or I'm sorry, from 100 to some other number, all the angle values would change, but they still have to hold on to the relationships that are already there. Okay? Now, the thing to check is does the triangle sum theorem hold true for this particular diagram? In other words, are the interior angles of the green triangle supplementary?
Yes.
Absolutely. And so like now the big question in terms of like mathematical thinking is now to ask yourself, does that apply to all the cases? And given what we've done so far, if we start changing like this 100 and this 120 to different angle values, will the change of angle still result in supplementaryism? Now, how many cases would we have to investigate to really answer that question? A lot. Nah, do better than a lot. You're right about a lot, but do better than that.
Infinite.
We'd have to do infinite number of cases. And so to convince ourselves of the truth, we have to take one of two pathways. One, we have to prove this is true for all the cases. In other words, prove it's true using variables. We can do that, but that's kind of outside the scope of what I want to use our time to do today. The second thing we can do is something called proof by immersion or proof by overwhelming cases. In other words, we can kind of look at multiple cases at once and then do some spot checking to see if the case still holds true. So I'm using something called GeoGebra. You may or may not have seen this in the past in other classes. It's something that I don't know how much we're going to get to use today, but it's actually some really wonderful stuff to figure out mathematical ideas. And so I built the same diagram. I built these to be parallel. I know they're not marked, but please trust that they are. And I built the thing that we just built together. But I can move this around. So can you guys get a calculator either on your phone, whatever, computer? I just need you to do some quick addition for me. And can you check that right now our beginning case, the interior angles of this triangle add to 180 degrees?
Math, it goes to 180, yeah.
Okay. And it might be off by, cause I turned off rounding, so it could be off by plus or minus 1 degree, but please understand that's only because I turned off rounding. And so what we can do is actually move this around. So I can take like this point C and I can kind of move it to different locations. And I can take this line and kind of move it around too. And so I've definitely moved it to a different configuration. Can you guys confirm that we're still at 180? And give me a thumbs up.
We're good.
Okay. And so like certainly for this kind of triangle where it's like roughly equilateral, where I keep point C relatively in this location, all these examples I can stop pretty much anywhere, but we can see it's going to be equal to 180 degrees. What other types of triangles should we check this for? Because right now I have what I basically call an acute triangle where all the angles are acute. What other kind of triangles should we test?
Right triangle.
Okay, we can do that. So I have to reconfigure this until one of the angles is right, which is right there. Check on the angle values. Are we still at 180 degrees? Okay, we can
Yeah.
Yeah.
Okay. And so I'm going to try to keep it 90, still at 180.
Yep.
Roughly 90 there. Okay. We can move the 90 to this side. There it is. 48 and 42, that makes 100 plus a 90, that's 100. Or I'm sorry, that makes 90. Plus a 90 makes 180. Okay. Now we could do this all day, but we're convinced it works for acute triangles. It definitely works for right triangles. What's the only other type we should check?
Obtuse.
Okay, so let's make one of the angles larger than 90, something like this. Okay, do a quick check: the green angle, the purple angle, and then the orange angle.
That's right.
Yeah.
Okay, let's do something a little more. Let's do something a little more extreme, shall we? Okay, so I have 164, 163, 10, and 7 are my three angles. So 163, 10, and 7.
Yep.
Yep.
Okay.
10 and 7.
So if it works for acute triangles, it works for right triangles, it works for obtuse triangles. What can we conclude?
It works for all triangles.
Yeah,
Well,
and that's
but it works for most triangles.
well, and so like which kind of triangles did we miss out on, Ethan?
Isn't there like an isosceles type of triangle?
Sure, I saw. So you're actually looking at one right now. Hold on. There, that's an isosceles triangle right there.
It just
And
means
so
you have two sides that are same.
Yeah, and so
Okay.
when you classify triangles, you tend to classify them by their angles first, and then like isosceles is a subtype of a triangle. And so what I'm trying to expose you to, honestly, a little bit here too, is a little bit of geometric thinking. And so this is actually how you build a dynamic case for or against an idea. So you test all the possible scenarios, you test all the possible cases, and if it's true across the board, then it has to be true all the time. And so if the triangle sum theorem holds for acute triangles, if it holds for right triangles, and it holds for obtuse triangles, it's reasonable to say that it holds for all triangles. Okay. Thumbs up if you're with me. Okay. So, having said that, now that we now have a theorem that relates it to angles of interior angles of a triangle, we have some idea why that's going to work. So let's examine another relationship, this time about exterior angles. And thanks to our work this morning, we know where the exterior angle of a triangle is. Okay, so keep in mind that we're going to simply take one of the side lengths and extend it out. Okay. And the exterior angle in this case, I'm going to label angle 1. So there are two relationships that are worth examining here. The first one is super boring. The other one, I think, will be a little more interesting. And so let's talk about this angle being angle 2, this angle being angle 3, and this being angle 4. Okay, so let's get the boring relationship out of the way. Why am I calling this one the boring relationship?
Because you're just adding all the angles together. Well, no, you're just adding 1 and 2 together.
Yeah, but why am I calling that the boring one?
I don't know.
Fair enough. Why is this one true?
I was gonna say you were calling it boring because there's not much to the problem. There's not much to challenge your mind.
Yeah, but no, absolutely. I think because we've covered this one for weeks. What's the reason why angle 1 and angle 2 are supplementary?
Because they are equal to a line.
Yeah, what's that called again?
Your pairs.
Yeah, so we know about the linear pair relationship, and so this one is kind of like the boring relationship. And so the more interesting relationship has to do with the other angles on the interior space. Uh-oh. My board froze. Come on, board, do your job. Nice. Okay. And so, like, the real big question here is how do angle 3, angle 4, and angle 1 relate? Again, I'm going to claim I think everyone here kind of knows how they relate. Here's why I think you guys know that. Is there a relationship between angle 1 and angle 2? Well, yeah, we just figured that out. Is there a relationship between angle 2 and 3 and 4?
Yeah.
What is it?
They're all supplementary.
Okay. So is it true that if I take, if I consider like 180 degrees, that's the same thing as a measurement of angle 3 plus a measurement of angle 4 plus a measurement of angle 2? Uh-oh.
Would that mean that angles 3 and 4 together are the same as angle 1?
Let's see if we can prove that. I like that. Who just said that, by the way?
Anna?
Anna? Okay, Rockstar. Let's see if that actually turns out to be true. So like, first of all, do we agree that the statement I have in pink is true? If I take 3 plus 4 plus 2 is equal to 180 degrees, what would justify that?
If you found out the angles of measures 2, 3, and of the angle of 2, 3, and 4, that should equal 180 degrees.
Yeah, how do I know that's true? Like, justify that for me.
Doesn't the inside of an angle equal 180 degrees?
What are you quoting? What's the theorem that you're quoting right now?
The triangle sum theorem.
Yeah, so this is true by the triangle sum theorem. This is the other abbreviation for triangle sum theorem. You draw a picture of a triangle, then ST stands for sum theorem. Okay, and you guys just told me a second ago that it's also true that the measurement of angle 2 plus the measurement of angle 1 is equal to 180 degrees. And you know this is true by the linear pair postulate, LPP. Now, Anna made this claim. That means like there's some relationship between these two equations. What do you see that could actually help me combine these two equations together? Is there any similarities in the two equations?
2.
Okay, so you see a repeated angle 2.
Equal to 180.
And they're both equal to 180 degrees. All right, so time to turn the algebra, turn your algebra brain on. If you have two equations that both equal the same thing, then what's true about their pieces?
They're congruent.
Or they're at least equal, right? And so
yeah,
if they're both equal to 180 degrees, algebraically speaking, that means the measurement of 2 plus the measurement of 4 plus the measurement of 2 would have to equal the measurement of 2 plus the measurement of 1. Okay. For cool points, what's the mathematical idea that allows us to do this? Starts with a T. Okay. So we had this addition that's equal to 180, and 180 was equal to this other addition. Therefore, the additions are equal to each other. That's an application of the transitive property. But now we have it in this workable equation. Ethan, I think, pointed out that we have measurement of angle 2 in each equation. And so how can I get rid of them?
Subtract.
You subtract them from each side?
Absolutely, we can. Because the measurements are just numbers, they behave just like numbers. Therefore, it has to be true that the measurement of angle 3 plus the measurement of angle 4 is equal to the measurement of angle 1. which is, by the way, what Anna predicted about 3 minutes ago. So this is known as the exterior angle theorem. Now, there's lots of different ways to write this out. I think it actually gets more confusing to try to explain this in words. And so I tend to think of this just in terms of the angles. And so I take the two outside angles, which are 3 and 4. These are sometimes called remote angles for what it's worth. It's always going to be equal to the interior set, or the exterior angle on the opposite side. Okay. And just for the good of visualization, because I do like visualization, and again, this is completely predictable because we know two things: a triangle sum theorem, and we know the linear pair postulate. A combination of those two, a literal combination of those two, results in this exterior angle theorem. Questions for me about what you've seen so far? Okay, let's try some then. So I'm gonna leave you alone for about 3 minutes. In those 3 minutes, can you just find the missing values? And so identify the proper application, triangle sum theorem or exterior angle theorem, and please calculate the missing values. Okay, so I'll come back in about 3 minutes.
Shoot. Jesus.
Okay, if you haven't yet, notice that the answers are up on the board. Can you please double check your work against mine? And also what you're seeing on the board represents the minimum amount that I expect to see, say if this was a quiz. I'm not entirely concerned with the steps of algebra, but I do insist that I see the equation you set up. And also the identification of like the theorem. In this case, TST is triangle sum theorem. EAT is exterior angle theorem, which is fun to write because it says EAT. Okay. So can you do me a favor? First, if there's any questions, what can I do to help you understand this better? What questions do you guys have?
Did you just add 75 and 36 to get x?
Correct. And so by the exterior angle theorem, the two remote angles, the ones not touching the exterior angle, in this case, these would be the remote angles, have to add to be precisely what the exterior angle is, in this case, x.
Okay.
You also see that here in the next example, definitely exterior angle. And so the two remote angles add together to make 146, which is the exterior angle on the other side.
Mr. Collins,
Yes.
the second triangle, how did you get 6.25? I got 6 and then I did the equation again and still got 6.
I got 6 too.
Well, I might have, I'll be honest, I might have misadded. Let me, do you guys agree with my equation though?
Yeah.
Okay, let me just, oh, you know what? I forgot the 2, didn't I? I never subtracted off the 2, so let me recalculate it. So 180 minus 2 minus 70 minus 60, divide that result by 8, and I get 6. Thank you. Oh, not negative 6, Collins, come on.
What did you say EAT means again?
Exterior angle theorem. This guy right here. EAT. Okay, do me a favor then. Can you put this in the chat, or can you just give me a visual if you're on camera? Can you just give me a 1 to 4 rating, no decimal points, commit to a 3 or a 4 or 2 or 1? What's your confidence that you can do these types of problems moving forward? Sweet. Okay. So let's engage into a little bit of practice, and then we're going to wrap up class. So I think I just need you guys for about 15 more minutes, and then no, come on, Hannah, you gotta commit to a whole number. All right. So can you guys please go here? So I just put a link in the chat. We're gonna do a little pair deck. This is gonna be a little bit different than the one that you guys did with Ms. Jaco. You guys had to do a lot of typing in this one. I actually want to do a lot of writing. And so I just have, I think it's like 9 problems max prepared for you guys. I just want to see you guys work these problems out so I can actually see your work. And then we'll end the day. So I think about 15 more minutes max, and then we're done. Assuming this ever loads. Okay, so it looks like you can go to the joinpd.com, or you can click the link that I have and then join. And then it looks like Insincere Bandanas Perfectly Quiz Orange Quizzes. Wow. Here's also the direct link is in the chat as well.
And where do we go for the? Oh, do you just hit join a session?
Yeah. So if you access the second link that I put into the chat, that should take you directly there.
IB.
Mine's not wanting to work, like, at all.
What do you mean?
Like, it doesn't want to load.
Okay. Can you make note of this code, and just in case you get kicked out, or maybe that I have to start, you can at least keep trying to get in. I'm going to load all the questions. I haven't done it yet, but I'm going to load all the questions up from the pair deck, so you can still practice, even if you can't practice right now.
Yeah, I just took a picture of the code.
Okay. It's an unfortunate. Yeah, it's not the best situation, but at this point, in 20 years, you're going to have to explain this period of time to your kids or something, and it's going to be a wild explanation.
Is there supposed to be a space in between that?
I don't know. It's just it decided the only thing that's not going to load. Everything.
I'll try to look more engaged.
Might have to redo it, restart your laptop. How long has it been since you last restarted it?
This morning. I restarted every night.
Oh, never mind.
I mean, that's the only thing that's not loading. I have other things that are open, like Schoology and Home Access and stuff like that. But that's the only thing that's not loading.
It might be because
you could have too many tabs open.
I only have 3 tabs open.
It could just be, honestly, Joy, it could just even be the connection in your area right now. It happens. Just keep trying to join. Like I said, I'm going to collect all these problems, put them out, make them available offline too. Okay, guys, you should have the first question up, and so I just need you to write on your screen. I know it might not be the cleanest thing because you may not have access to a stylus or something, but just do the best you can to respond on screen. I'm looking just to see what the responses are. And then find the value of the unknown. This should be real quick. I'm going to give you about 30 more seconds.
What?
Okay, but if you're gonna respond, I'm gonna take about 10 more seconds total, and then I'm gonna talk through some of the responses. Because although it seems like a lot of everyone kind of has the idea, about half of you guys just failed this question.
Jeez.
Okay, and I just want to highlight some thoughts for you. Okay, these are actual student responses. If it's yours, I'm not trying to call you out. They are anonymous, so I don't know whose. And so, first of all, did this person get the correct value for the unknown angle?
Yes.
Yeah, 40 is absolutely the measurement of angle U. If I were to grade this, if this were a quiz and I were to grade this, I would give this person no better than a 63%. Okay, and here's the reason why. The question clearly says that you have to identify the applicable theorem, set up an equation, and then solve that equation for the value. And so that person did none of those things. I'm not saying their answer is incorrect, but I need to see all the things in order to give you credit, because this being not an algebra class, getting the correct answer is important. However, identifying all the pieces are equally important. Okay, here's another example of someone who also would not get a full score. I don't know if they just stopped working or what exactly happened. I'm not passing judgment, but they did one of the three things. And so I would give this person, again, no better than maybe a D. Now, the reason why this would get a higher score is because they're showing me the geometry, and the geometry has to do with the theorems and identifying the diagram. So this thing that we've been saying in class, like, hey, recognize the diagram, identify the relationship, that's the big geometric piece. And so this person would score slightly higher, but still would not have a passing grade. They haven't convinced me that they understand like the connection between the theorem and then the relationship and the behavior, even though they did identify the correct relationship. Right? This would be an example of a perfect answer. Oh, no, never mind. That wouldn't be a perfect answer. What did this person identify incorrectly? Oh, never mind. They went a different route. Never mind. This is a nice alternative. So it looks like they use linear pairs to get this one, and then they use triangle sum theorem to get this angle. I think that's perfectly fine. I think it's more directly applicable to the exterior angle theorem, but using the triangle sum theorem here, I think is good too. So that would be an example of a perfect answer. Here's another example of a perfect answer. I see the theorem, I see the equation, and then I see the response, the answer. This is obviously a simple calculation one, but all those pieces are important to me. Okay. Questions about that? Like questions like what I'm demanding in terms of setup and stuff. Sweet, let's move on. So let's solve this one. Okay, 30 seconds on this one, guys, and we're moving on. So please pay attention to the instructions. Please make sure if you were one of the ones that made the mistake, you're not making the mistake in the future.
I can't see the slide.
In the presentation. So if you look at your screen, it should be what I have. It should be a triangle with 35 and 88 in it. Do you not see that?
No, sorry.
What do you see?
I just see a blank screen. I see gray.
Okay.
I'm gonna like refresh it or something.
You're not in the Zoom meeting, correct? Like you're not looking at my shared screen in the Zoom.
I am now.
Okay.
But I wasn't before.
That's just a problem. Like if you look at your Pear Deck screen, like whatever browser window you have open, you should see the new question.
Okay.
If not, you can just do
it now.
Perfect. It might just be a refresh issue. Right. Again, if I end up pulling up yours as an example, please don't take it as anything personal. I'm just like picking out responses, and I want you guys to see them. So as a class, can you guys tell me what is wrong with this one?
They used the wrong theorem.
Yeah, and so there's no exterior angle identified on this diagram. Remember, the exterior angle is an extension on the outside of the triangle. And so even though you do have two remote angles, and you could probably tell me the exterior angle, this is not precisely what we were looking for. I wasn't talking to you, Siri. Okay. Here's another example. Now, they did show the equation. This is an example of something that would get graded at probably like a 50% because you are showing algebraic knowledge, but not geometric knowledge. This is not the proper relationship because, again, 57 is not an exterior angle. 57 is an interior angle. So that's not what we're looking for either. Okay. What is wrong with this one?
They added 35 plus 88 to get 57.
Yeah, so again, I'd point out they're doing an exterior angle thing, or they're attempting to. They did do something importantly correct, which is they did identify the triangle sum theorem as being the correct theorem, for sure. Can someone just shout out to the room, what does the triangle sum theorem say?
The three angles added together equal 180 degrees.
And I don't see that equation off to the right. So they correctly identify triangle sum theorem, but their equation definitely does not back them up. Okay. If you're using alternate interior angles, what has to be present in your diagram?
Transversal.
And what else besides that?
Parallel lines.
Which we do not have. And so I believe this person actually calculated the answer correctly. This equation is nonsensical. 35 plus 88 is not 180 degrees. But I think they were trying to find the remaining piece. I do believe they did it correctly. But your equation does not follow. Okay. And so even though you have the correct answer, you have the incorrect justification, incorrect equation, I would grade this at a 50%. Okay. Not a personal admonishment. This is like the chance you can use to get better. Okay. Here's an exemplary answer. I'd probably give this one 100%. So I see the triangle sum theorem correctly identified. I see the equation they used to get it. Although like all the steps aren't present, I don't care about the steps, but I have to see the translation to thinking. I would say that would be 100%.
Whoa.
Okay. What is this person missing?
The theorem.
Yeah, and so I see the great mathematical calculation. I don't see the theorem, even though the right answer, I cannot give this 100%. Okay, guys, so this please be wary as we're solving a couple more of these. That counts, and so you definitely have to make sure you're following all the instructions. Let's try this one. Okay, so let's make sure we have identification of the proper theorem, equation that backs that up, and then a solving methodology that gets us to the answer. Can someone tell me on their end, are you seeing me scrolling through screens and is that taking over your screen? Or are you still able to work?
I'm still able to work.
Okay.
How do you submit this?
I don't believe that you do. I can. It's a live writing tool, so I can see.
Oh, okay. So you just see it.
Yeah.
Okay.
Okay, about 20 more seconds. We'll move on.
Can we have a little more time?
Yeah, I want to. I can't give you a ton more time, but go ahead and keep working.
Hey Alexa, what's 180 minus 116?
Alexa to the rescue.
When it comes to like this and I don't want to like run out of time, I just ask Alexa.
That's fine. Listen, I have no problem with you guys using your tools to do the calculations. That's what calculators are for. You essentially just ask Alexa to type stuff into a calculator. So.
Yeah, well, I got yelled at by my friend's mom. She's like, "That's not doing schoolwork," and I was like, "I only use it for the big problems."
Hey.
Yeah.
I was like, "And what's the difference in using a calculator at school?" She's like, "You don't have Alexa at school or Siri."
I don't know. I kind of argue that you do. Can everyone see the screen I'm sharing that's written in red?
Yes.
Yep.
Okay. Can we all take a moment and this is actually an incorrect response. Can we give this person some advice about what they did incorrectly and what they need to do in the future to get the answer correct?
They were using the equation for the triangle sum theorem instead of the.
Yeah.
So
No,
it shouldn't be set equal to 180. The 7y plus 6 plus 4y should be equal to 116.
Yep. So the advice I give this person is to go back and review their notes about the exterior angle theorem. The two angles that aren't the linear pair, so these two remote angles, and I don't know if you can see what I'm pointing at actually, but the 7y plus 6 and the 4y, the two angles that do not touch 116, those add to make 116. And so this person definitely used the triangle sum theorem equation, although they did correctly identify exterior angle theorem. Okay. Can someone give this person two pieces of advice about how to improve the work?
They could do the theorem, like name the theorem that was being used.
So right off the top, they did not identify the applicable theorem. What's the other thing they did? They need to change.
They equaled it to 180 degrees.
Yeah, so an incorrect equation connected to the theorem itself. And you should really think of this, guys, about what to change in the future, so future problems. Okay. Advice?
Do the equation.
Yeah, I see an answer, or at least for the angle values, but the question actually asked for the unknown value. So I actually was looking for the y value. I don't see an equation. I could give this person at best a 50%.
I've been answering it on my drawing tablet.
Sure, and if you're doing it offline, that's fine. I'm just taking this opportunity to show like what good examples look like, and how to improve the ones I don't like. This would be an exemplary answer to me. So I see the exterior angles as the answer. I see the equation that's set up. I see the answer. So those three together for me are exemplary. Sorry, in case you want to screenshot it, you're welcome to. Okay, but those are the three elements I'm always going to be looking for. What's the relationship? What's the behavior? And then, of course, the solution, whatever that question may be. I do want to bring up this one. And there are more than one exemplary answers here, right? Linear pair, although definitely involved, is not the relationship we're looking for. Linear pair would give you the other angle at E, the interior pair, but it would not be applicable to solving for Y. I just see another one. It is EAT. Looks like they changed it. Never mind. Okay. Let's move on to the next one. I don't know if you knew this, whoever's writing in the red pen, but you can make that pen smaller, like less thick. It might be easier to write.
Man, I hate this.
Okay, I know some people are still kind of in the working phase. But what do you have in front of you? I think what I'm currently sharing on my screen, I would say that's an exemplary answer. I clearly see the theorem, I clearly see the equation, and then I have the work itself. The step the student's currently putting in, I think, is a good check step, like substitute that number back in to make sure it actually adds the way you think it should add. And clearly it is adding the way it is. Here's another exemplary example. So I try to be gentle with the first two examples. So the one that's currently on the board, I see some things are being added to, which I think are fine. But like, if this was all that was given to me on a quiz, I would have to give this person a 50%. I see the correct answer. I don't see how they got there, how they justified it. Those two pieces are just as important. And so this person in his current form would get a 50%. That one's good. Here we have an incorrect justification. I think linear pairs are going to get you there, a person who's currently typing. However, if you're going to use linear pairs, looking at this equation, what's the actual theorem that they're using? The 4y plus 4 plus 52 plus 3y equals 180. What do they seem to be using?
Triangle sum theorem.
Although they did do it incorrectly. What's the number? If you look at that equation, what number is actually incorrectly being used?
180.
No, not 180. 180 is good for triangle.
Oh.
Yeah. So they'd actually have to find, using linear pairs, they'd actually have to find 128 to be the interior angle. Right? And so they have to, like, using linear pairs. Well, this right. So let's see. Yeah, so they can determine, like, that's 128 degrees. And then they can change that up to be 128. But the actual justification will be triangle sum theorem. If you're looking at the shared screen on Zoom, I made some edits to it, like, and that would actually work out to be a good score. Okay, let's so x equals what, 8, I think, is what we're looking for.
You mean y?
Yeah, y. Thank you. Okay, let's try this one real quick. Okay, I promised you 15 minutes. We ended up extending a little bit more because I wanted to be confident that you guys were in the groove of solving these, and I have seen improvement over the last couple of examples. But let's just go over this last one together. And so please check out the screen I'm currently sharing. The responses I'm sharing. What advice would you give this student? Because this student would not receive 100%.
They're
Triangle
using the
sums.
wrong theorem. It's supposed to be TST, but they have the right equation.
Yeah, everything else is perfect. That should be triangle sum theorem. Again, we're not dealing with axial angles at all. And so that's what the advice we can give that student. That looks good. That looks good. Advice? Oh, no.
Like the theorem that they're using?
Yeah, there was no theorem on that. That looks great. Aw. What happened? Yeah. It looks like they have no actual work here. And so just so you guys understand how I'm going to be grading this would probably receive a minimal score. It would not receive like a low level F because you are correctly identifying the theorem, and that is worth a lot in geometry. But yeah, we definitely have to see some work to kind of back that up. Okay, looks like this person just didn't finish. That's good. This is actually a perfect score to me too. I see the theorem, I see the equation, and then I see the answer. So I see all three things that we could use that I need to prove the relationship. Okay. Are there any questions about like the problems we're currently doing? I'm seeing improvement across the board. I'm not showing every single response, of course, but I'm seeing overall improvement. Is there anything I can answer or clarify for anybody right now?
What does TST mean?
Triangle sum theorem. And so it's just a shortcut for the triangle sum theorem. Same thing with EAT. Like that's just a shortcut for exterior angle theorem. Okay, I'm jumping up to slide 10. Let's just do this last one, and I think we'll wrap it for the week.
Jeez.
So you can just write them into the areas. Can you please find these angles?
Why?
You say why?
I mean, good
Oh,
Lord,
on.
Mr. Collins.
Yes, why, Mr. Collins? Why?
Oh, this is easy.
Friday.
I was feeling so confident for so long.
And then
Not relate.
Really had to do this to me. Really had.
Hey, I'm feeling benevolent, so I'll give you guys even a hint. I wouldn't start with angle 1. I would start with angle 2 or angle 4. Look at that. I even gave you a hint.
My senior best friend who's sitting behind me is just like, oh my God, I'm glad I'm not in geometry no more.
Oh.
Wow.
Thank you, question mark.
He's in his own Zoom meeting.
I'm not in Zoom.
In Zoom?
not in Zoom.
Did you say Zoom meeting?
He's watching Minecraft tutorials.
No, I'm watching about the Apple Car thing.
Really?
Yeah.
For the first time ever, you're not watching Minecraft videos.
And I'm doing other things too, like.
You guys notice on this one, I don't actually need you to write down the theorems or anything. I just need you to generate the values. And so, like, you just go ahead and generate the values.
Because I'm not sure anybody would do that.
So would this be on the test or quiz?
Oh yeah. This is totally fair now.
Thanks for that.
You're welcome.
He sounds like so happy that it's on the quiz.
Oh yeah.
Like the one you'll see will probably be more complicated because there's no parallel lines on this one. Uh-huh.
Thanks, Mr. Collins.
You just make this more fun and fun by the minute, don't you?
I try to. That's my job.
No, you're done teaching math.
With my new glasses, it is still hard to see this.
My glasses got scratched yesterday. Now there's just a big line, and
This is the first time I've had glasses in 5 years. So this is the first time in 5 years that I actually can see things. And oh my gosh, I was in tears when I first put them on. I was just like, oh my God, I can actually see. My grandma ran into me when we were at the door. I was like, I could see the other side of the parking lot. My grandma smacked me across the back of the head for that one.
What was that?
I don't know, but my laptop. What's going on? What hell? Yeah.
Okay, guys. If I can get your attention to, actually, can I get your attention to the Zoom screen might actually be a little better because I'm doing a little writing here. A problem like this looks intimidating, but you have to understand, you know, all the relationships. And so everything we've done up to this point has been to build your knowledge of relationships. When you look at a diagram like this, you have different ways to attack it. And I think the student that I currently have up, they attacked it multiple different ways, and I'd like to highlight some of them. How do you know that angle was 40? What relationship did he use?
Linear pairs.
Absolutely did. Linear pairs supplementary, so of course the angle would have to be 40. I don't know how the student engaged it. I'm just going to take some guesses here. I think he probably figured out 72 next. The one I currently circled, how do you know that was 72? What relationship?
Vertical angles.
I agree. So vertical angles of 72. This may not have been that student's thought process, but it certainly would have worked. How do you figure out the 108s?
Again, vertical.
Not vertical. I don't think so.
Linear pair.
Yeah, he'd probably have to use like a linear pair approach, where so 72 and angle 4 are supplementary, therefore it's 108. Maybe vertical's got him the other 108. How do you figure out 68 then? He or she, excuse me. Because he'd have 72 at this point, and he or she would have had 40 at this moment.
Minusing 40 from 108, maybe?
Yeah, what relationship?
To find 68.
Yeah, what relationship?
I would say TST.
Yeah, triangle sum definitely would apply there. It looks like there's some repeated reasoning on this side. And so vertical angles would have got 135. Linear pairs would have gotten 45. Triangle sum would have gotten 75. Linear pairs to get 105. And of course, this last at the bottom would be another triangle sum theorem. So someone asked, would this be fair for the quiz? Absolutely be fair for the quiz. It incorporates all the different angle values, all the different relationships we talked about up to this point. Okay. Guys, I did promise a short session and we ended up running long. I truly apologize for that. I didn't think it would. But I just want to give you guys a chance to see some of these worked out so you're not making mistakes or minimizing your mistakes. Okay. In terms of what you owe me, if you look in today's folder, this presentation is there. I'm going to drop an offline version of it so you can see the problems if you want to work them out just for practice. Also in that is another cycling homework worksheet. Again, those aren't explicitly due, but you know they're going to inform the quiz. The big ticket item though is going to be the quiz due tomorrow at midnight. And so that by far is your priority, and then everything else is just practice. All right, questions for me before we wrap it up?
Yeah, I'm kidding.
All right, guys, that's the weekend. You guys have a good weekend.